Hello everyone. So in this video, we're going to be looking at an ALEKS problem about interconverting number of atoms and the mass of a compound. So this is really good practice for your dimensional analysis and getting used to the more mathematical aspect of your introductory chemistry. So we're given a mass, we're given that we have glucose, and we want to find the mass of the glucose compound that contains 1 times 10 to the 6 carbon atoms. So with these problems, I find it useful to kind of write out what you have and write out what you need. So even if it seems obvious, I just write down that we have 1.0 times 10 to the 6 carbon atoms. And it doesn't look like we're given anything else, but technically we are given something else. We are given that we're finding the mass of glucose. Now, in order to find the mass of glucose, you're going to want to know what its molar mass is. Remember, molar mass is grams per mole. So that is the number of grams in 1 mole of a substance. So that's going to be very useful when finding molar mass. When finding the mass of anything, really. So, to find the molar mass of glucose, we need to, from the periodic table, we need to get the molar mass of carbon, the molar mass of oxygen, and the molar mass of hydrogen, and add up the amount of those atoms we have in the compound. So, we know from the periodic table that carbon has a molar mass of 12, and we have 6 of them. Hydrogen has a molar mass of 1.008, and in our compound we have 12 of them. And oxygen has a molar mass of 16, and we have 6 of them. So what that's going to look like is the molar mass of glucose, C6H12O6, is going to be equal to 6 times the molar mass of carbon, which was 12.01, plus 12 times the molar mass of hydrogen, which was 1.00. I'm actually going to use the ALEKS value. On ALEKS, it's a little bit more specific. It gives you 1.00784. And then plus 6 of the oxygen molar mass, which the ALEKS value for oxygen molar mass is 15.9994. And remember our units. The units for molar mass are going to be grams per mole. So if you do the calculation for this, you find that the molar mass of C6H12O6 is equal to 180.14808 grams per mole. Now, I like to leave as many decimal places as possible in the calculation portion of the problem. It does say in the problem that you should round to two significant figures, but I usually wait till the end before I do that, because the more information we have, the more accurate our answer will be in this case. So if we have the molar mass of the compound we want to find the mass of, and we also have a number of carbon atoms that we want, we can do a little bit more dimensional analysis. What else can we know about this problem? What else can we deduce? Well, we have a number of carbon atoms. It's probably going to be helpful, since we have grams per mole and we want grams, we are solving for grams because we want to know the mass of this compound glucose. So we don't want moles in this molar mass. So it's going to be helpful to convert our atoms to moles. Now, how do we convert atoms to moles? Well, remember Avogadro's number. So Avogadro's number is 6.022 times 10 to the 22nd. And this number by itself is technically unitless. You could have 6.00 times 10 to the 22nd apples, or oranges. But the point of Avogadro's number is that it represents a mole of something. Just like, for example, if you have 12 donuts, you have 1 dozen donuts, if I could spell. With the same logic, if we have 6.022 times 10 to the 22nd apples, we have 1 mole of apples. It's the same thing. A mole is just... It works the same way as a dozen does. It's the same concept. So, when we're given that we have 1.6 over here, 1.6 times 10 to the 6 carbon atoms, we want to find out how many moles there are. So, how do we do that? Well, we set up a fraction. And this is why it's very important to write out your units, because this is good practice for canceling. The rule of thumb is that whenever you have something like grams per mole, and you want just grams, you need to multiply it by moles, so that the moles cancel and you're left with grams. So we're going to apply that same idea to finding how many moles of carbon we have. So we write out 1.0 times 10 to the power of 6 carbon atoms And what we do is that we put these carbon atoms on the denominator because we want moles, and we multiply that by Avogadro's number with the appropriate unit. So 6.022 times 10 to the 23rd atoms over 1 mole of carbon. Because regardless of whether this is, once again, regardless of whether this is apples, oranges, hydrogen, carbon, there is always 1 mole in 6.022 times 10 to the 23 atoms. And so, this ends up just being Avogadro's number divided by 1.0 times 10 to the 6. And if we do that calculation, we get that we have 1.66058 times 10 to the power of negative 18 moles of carbon. Now notice, this is a very small number. So that means that the mass we're going to be finding is probably going to be really small. So let's take this value and move it down over here, just so that things are a little bit less chaotic. And let's see where we can go from here. So we now know that we have 1.66 times 10 to the negative 18 moles of carbon. Now, we want to know, remember what we're solving for. We're solving for the mass of glucose, this compound here. So now what we have to ask ourselves is, if we have a value for how many moles of carbon we have, how do we know then how many moles of glucose we have? Well, notice that for every 1 mole of glucose, we have 6 carbon atoms. That means there are 6 moles of carbon per every 1 mole of glucose. So, as we did before, we can write that out as a fraction. We can multiply our moles of carbon times that fraction that we just found. So for every 1 mole of C6H2O6, we have 6 moles of carbon. Now, moles of carbon and moles of carbon cancel, and we're just left with this number divided by 6. And that will leave us with the units, moles of glucose. So divide this number by 6, and you will be left with 2.768 times 10 to the negative 19 moles of glucose, C6H12O6. So we're almost there. We now have a value for moles of glucose. Now notice that our molar mass of glucose is 180.14808 grams per mole. And so that will cancel out nicely if we multiply this by 180.14808 grams of C6H12O6 per 1 mole C6H12O6, then the moles of glucose, right? Those units cancel, and we are left with 180.14808 multiplied by the moles of glucose. And if you multiply those numbers out, you are left with 4.9858 times 10 to the negative 19 grams of C6H12O6. And that is almost our final answer, because remember, we want 2 sig figs, right? So if we round this to 2 sig figs, we are left with a final answer of 5.0 times 10 to the negative 19 grams of glucose. Now, when you're filling out ALEKS, it won't be necessary for you to write glucose. All it wants, because it says in the problem here, be sure your answer has a unit symbol. That means all you need to write for your final answer is 5.0 times 10 to the negative 19 grams, and that will be your final answer. Now, there's a little bit more math in this problem. It's kind of intimidating. It takes a while to get used to. If you don't understand it, I encourage you to ask your professor for help, because what we solved here is essential for not just chemistry, but every math, any math-based subject that you take. And every subject has math in it, even biology, though everything has math in it. And so learning how to cancel out units like we did with grams per mole and atoms per mole and whatnot, learning how to do that is such an important tool to have when it comes to exams and when it comes to the future of your education. So if you're still a little confused about this, it's understandable. I did my best to explain it, but this requires a lot of practice. So I encourage you, please practice this on your own, and if you have any help, or if you need any help, ask your professor, or maybe even leave a comment on YouTube, and I can try to get back to you. All right. Thank you very much for watching, and I'll see you in the next video.